Hello everyone. So for this next video, we're going to be talking about triangle similarity. All right. So first of all, the main thing you have to understand what a similar polygon is. All right. So essentially similar polygons are polygons with the same shape, but a different size. Okay. So like a good way of thinking about it is like saying, okay, well, let's say I have this nice little big square right here, right? All right, a square that would be similar to that would be like either a zoomed out version or a zoomed in version, but every other property about that square is exactly the same. All right, same thing if I had like, maybe just a big triangle like this, right? Maybe a similar triangle would be one that looks exactly like that, but like maybe a zoomed out version of it, like just a tiny version of that. Okay, and what you're going to see is that there's a lot of similar properties that they have with each other, right? Hence the word similar polygons. All right, so you know that polygons are similar if they have corresponding angles that are congruent. So corresponding angles are congruent. And we also know they're similar if the corresponding sides are proportional. Okay, and that's part of the reason why before this section we started going over scale factors, because one figure is the scaled version of another, and we also went over proportions with you guys because we wanted to make sure that you all understood how to work out the math for that. All right, so when we talk about the ratio, so now the ratio of the corresponding sides is the scale factor, like I just mentioned. All right, and if the polygons are similar, then their perimeters are also proportional. Okay. So if this doesn't make any sense, it'll probably make more sense when we actually go through an example. So let's look at this one. It says list the congruent angles and write a proportion relating the sides. So here they're saying that triangle JKL, and now we have this symbol right here. When you only have just one little squiggly line, you're probably used to seeing the congruent symbol. Well, the similar symbol is the one without the equal sign. Okay, so triangle JKL is similar to triangle PMN. So we have JKL is similar to PMN. Now, here's the thing. Whenever you look at these triangles side by side, you know how like one is kind of oriented this way and the other one is kind of like turned around like that? What I always tell my students, and you're going to have the stubborn students who don't want to do this, but the ones who follow this advice almost never get these types of questions wrong. I personally would rather redraw one of these triangles to look exactly like the other. I'm gonna choose this one. So I'm gonna redraw this one, just a smaller version because that's a smaller triangle. I'm gonna draw it like kind of like that, sort of. Yeah, it's close enough, right? And then I try to match the letters with the with this figure. So here we have P is up here, so that means that J has to be up here. Let's see, M is down here, so that means that K has to be down here. N is down here, so that means that L has to be down there. And now I'm just going to forget that this triangle even exists, and I'm just going to look at those two. I promise you, if you follow this method, you're gonna be much better off in knowing how to set up your proportions and all of that. So now I can just look at this, and I know that N corresponds. So I know that, because remember, we said that the angles are congruent, right? So I know that N is congruent to angle L, right? And that's the thing. Even though this is a scaled version of the other, these angles are going to have the exact same measurements. What's really going to change between the two is the side lengths, okay? And what you'll notice, and then the other thing you'll notice is that P is congruent, angle P is congruent to angle J. And you'll also see that angle M is congruent to angle K. All right, so that's one of the things you really have to remember about similar figures, okay? The angles are the same, the side lengths are different, okay? But the side lengths are going to be proportional to each other. And what you're going to end up doing is if you see that MP corresponds to JK, you can actually set up a proportion with those two. We can do PM divided by JK. okay? And here's the thing: when you create like a, I mean, this is almost, I said proportion, but like this is essentially the scale factor of the two triangles. You can set up a proportion with these two versus any other two sides that can be, written as a scale factor. Now, the thing you have to be careful here is you have to make sure that you're consistent with what you put on the top and what you put on the bottom. If I put the segment of the big triangle on the top, for every other scale factor I use, the big triangle has to be on the top as well. So, okay, so I know that PM over JK, I can set that equal to PN over JL, right? Again, I'm staying consistent with my big triangle value on the top and my little triangle value on the bottom, all right? And then, of course, I can always set that equal to NM, big triangle value on the top, over LK, little triangle value on the bottom. As long as you stay consistent with that, you don't have to do all three of them. Most of the time, you'll just do either these two cross multiply and solve, or these two cross multiply and solve, or those two cross multiply and solve. All right. So this is kind of just like a prerequisite for how we're going to attack these problems. And we'll just start off with a simple one like this one. It says the figures are similar with a scale factor of 2 to 3. Find the value of x. So again, 2 to 3 is our scale factor. So what we can do is we can rewrite that as a fraction. Okay? And what we're going to do is we're going to set up a proportion. Now, obviously, you're going to have to use a little bit of common sense here. If it's from 2 to 3, the 2 is going to correspond to the smaller figure, and the 3 is going to correspond to the bigger figure. So if I want to set up a proportion, what I'm going to do is I'm going to go ahead and set this equal to the value of the smaller figure divided by its corresponding value of the larger figure. All right? And now this is just some simple algebra we can do. From here, I'm just going to go ahead and cross multiply. So this is going to become 2x. And then this will be 126. And then when you divide it by 2, you get x is equal to 63. All right? So let's move on to the next example. Here it says if we have triangle AGM is similar to triangle KXD, find the value of x. Here's another situation where I'm just looking at this and I'm like, some of you are probably good enough to where you can be like, oh, I'll just look at XD and that corresponds to GM, so this corresponds with that. I highly recommend that you just redraw your triangles. Take the time. It wouldn't take you more than a minute to do it. So I'm gonna use this triangle as reference. I'll just go ahead and redraw another triangle just like that over here. Okay, and I know that that A corresponds with K, so K goes down here. G corresponds with X, so I'm gonna put X up here, and then M corresponds with D, so I'm gonna put D right there, right? So now I'm going to go ahead and look at so I know XD from this one was X plus 6. And I know that XK over here is X plus 3. All right. Then I'm going to completely forget that this triangle existed. Now I can go ahead and say, okay, well now it's much easier to look at. I can see that the X plus 6 corresponds with the 36. And this X plus 3, since it's this slanted line versus that slanted line, it's X plus 3 corresponds with 32. So now what I'm going to do is I'm going to go ahead and maybe I'll do little triangle on top. So I'll do X plus 6 over the big triangle, or what its corresponding value of the big triangle, and set that equal to the X plus 3 divided by its corresponding value in the big triangle. So again, little triangle value over big triangle value. Little triangle value over big triangle value. I know I sound like I'm talking to a child, but I promise you that's like one of the biggest mistakes I see all the time. So I'm going to go ahead and cross multiply. Okay. And then I have, let's see, 36 times x plus 3 is equal to 32. And don't forget your parentheses when you have multiple terms like that. X plus 6. So then when I distribute, I get 36x plus, oh God, I have to do this math and it's early, 108 is equal to, and then distribute those two, is 32x plus, let's see, 12 plus 180 is 192. There we go. Okay, so let's see, I'll just go ahead and move the 32x on this side. I'll move the 108 on that side, do it all in one step. And then I have 4x is equal to, and why is it so hard to do math this early? Equal to 84. I understand your pain now. So then you, for those first period students, so then we have x is equal to 21. And there you go. All right. So those are the types of examples you see. The type you'll see mostly on the FSA and probably on any of our tests are problems like this. Again, please, please, please redraw your triangle. Most people would have said, oh, but XK corresponds with this one because aren't they both kind of like, no. Redraw your triangles and you can visually see which ones to set equal to each other because then the math is just algebra and that's the only hard part after that. All right. So if you turn your page, oh, I have it, I didn't print them out double-sided. Let me go ahead and find it. So now if you look at these now, a lot of times, you know, obviously this is geometry and obviously we are going to be doing proofs at some point. What you need to understand is how to determine if two triangles are similar. So they're going to sometimes give you a figure. You're going to have to look at all the properties and be like, okay, how do you know that these two triangles are similar? Here's the thing. If they have two angles that are the same, or if two corresponding angles are congruent, then the triangles are similar. And let me explain why. So obviously they've already established that this angle, angle V, is congruent to angle Y. All right. And then you have to look at this figure and be like, okay, well, is there any other two angles that are congruent to each other here? And then you look at that and you say, okay, well, I know I have vertical angles there, right? So basically, yes, they are similar. Yes, triangle WVX is similar to triangle. And then we got to make sure we do the corresponding. So obviously, if those two are the same, then W corresponds with Z. V corresponds with Y, and X corresponds with X. X is just X, okay? And the reason for that is because if you know these two angles, then you'll know the third angle. And wouldn't this third angle still be the same as that third angle? So then you have similar triangles, all right? The other way that you'll know is if all corresponding sides are proportional, then the triangles are similar. So let's go ahead and look at this one. First of all, I'm going to get 30 divided by 24. Okay, and let me see. I'm going to reduce this down as much as possible. If I reduce this down, I know they're both divisible by 6, so 30 divided by 6 is 5. 24 divided by 6 is 4. Okay, so I know that the scale factor between DC and GF is 5/4. If the other scale factors do not equal that, you cannot do this. So let's go ahead and try DE and GH. So we have 35 over 28. Well, let's see, they're both divisible by 7. So 35 divided by 7 gives us 5. And 28 divided by 7 is 4. All right, so far so good. So far we can say that they're similar, but we always got to check that third side. Now let's do 32 over 25. So 32 divided by 25. This is basically only divisible by 5. That one is not. There's no way that I can simplify this any further, can I? Because this is 2, 5, 5. Nope, there's nothing that'll cancel out. So essentially, no, they are not. These are not similar. Okay, not similar triangles. Okay, and again, even though two of them are proportional, the thing is, in order for them to be similar, all of the sides have to be proportional. All right, cool. So now let's look at this one. Ooh, see, again, you can try to look at it like this, but I would just rather redraw my triangles, okay? Some of you probably are getting annoyed with this, but I don't care because I'm going to get these questions right. So we have AED, and then we have ACB. All right. And let me see. I know that AC is 21. I know that AE is 12. I know that AB is 25 here. And I know that AD is 15. See, it didn't even take me a minute to go ahead and redraw all of those. And now I can kind of look at these. So here's the thing. The other way that you can tell if it's similar is with SAS. You know, isn't that how we also, well, SAS and SSS, those used to be ways that we can prove the two triangles are congruent, but they also can be used to determine if two triangles are similar. So what I'm going to do is I'm going to go ahead and say, well, first of all, if I kind of took these triangles apart, isn't the angle A the same as angle A? Right? Well, there you go. So the angles have to be, the one angle has to be the same, and then the other sides have to be proportional. So what I'm going to do is I'm going to have 15 over 25. And let's see, so if I do this triangle over that triangle, that reduces down to 3/5 because they're both divisible by 5. And then if I do the other one, 12 divided by 21, right? So they're both divisible by 3, but that reduces down to 4 over 7. See, that's a problem. They both have to be proportional. So no, not similar triangles. I wish we would have come up with some examples that they are similar so we can see it, but that's all right. So no, not similar. You have to make sure that the two sides next to that angle are proportional. If not, then you're not good to go. So that's pretty much all you need to know for this section. Hopefully that was helpful. And again, if you have any questions, feel free to ask any of us. Take care.